Okay, this is lesson 3.6 on interpreting the discriminant today. So what I have on the screen here is just a reminder of what we did in lesson 3.5. So in lesson 3.5, we were solving equations that looked like this: ax squared plus bx plus c equals 0. And we learned a new way to do that, which is by using the quadratic formula, which looks like that. X equals negative b plus or minus square root of b squared minus 4ac all over 2a. So it was a very complicated looking formula. We learned how to use it and how to apply it in the previous lesson. Today we're going to be looking at a specific part of the quadratic formula, which actually gives us a lot of information about the equation really quickly, and so then we can kind of go from there in terms of choosing a strategy and knowing a little bit about what types of solutions we're going to get. So the part that we're going to focus on is just the part that's underneath the square root, the b squared minus 4ac. And that we give a special name because it's so useful for us. We call it the discriminant. So if you look at the name of our lesson today, we're going to be interpreting the discriminant. So that number there, it tells us a lot about our quadratic equation. So if we calculate the discriminant, it will tell us how many solutions there are. And it will also give us information about what types of solutions we have. So for example, are the solutions rational numbers or irrational numbers? The discriminant will tell us. And also what strategies could we use to solve the quadratic equation? So for example, could the quadratic equation be solved by factoring? We can tell that just by looking at the discriminant. G's for solving. I ran out of space there. I'm just going to scroll down just a little slight bit. So by the end of today's lesson, the goal is for you to be able to, number one, calculate the discriminant, and then number two, use that to figure out how many solutions there are to the equation, what types of solutions there are, and what strategies you could use to solve that quadratic equation. For example, could you solve by factoring? Okay, so let's go ahead and start with just two warm-up questions because it'll motivate how we might use the discriminant in the future questions that we'll do. So we're going to do these two here, and we're going to start by solving using the quadratic formula. So the A, I'm just going to highlight the A, the B, and the C here. So A is 1, B is negative 8 in this example, and C is 16. So if I go ahead and use the quadratic formula, we have x equals negative b, so 8, plus or minus square root of b squared, which is 64, minus 4 times a times c, all over 2a. Okay, and then let's just evaluate what we have under the square root there. We have 64 minus 4 times 1 times 16. So actually that evaluates to 0. So we have 8 plus or minus 0 over 2. Now, adding or subtracting 0 doesn't actually do anything. So in this equation, it's kind of a special case. We just get one solution, which is 4. So let's take note here of what happened with the discriminant. When the discriminant is 0, we actually only get one solution. And also what we notice here is that solution is rational, meaning it can be written as a fraction. There's no square roots in the final answer, and there's no decimal that needs to be rounded. So we have a rational solution. In fact, actually, we could have solved by factoring. So whenever you get a rational solution, you could have solved that equation by factoring. So let's just see how that would have looked. So I'm just going to put a little arrow here, factoring. So if we look for two numbers that multiply to 16 and add to negative 8, those are going to be 4 and 4. And we see here that both factors are the same, which makes sense as to why we had only one solution before. Okay, so just in summary here, when the discriminant, which is this part here under the square root, is equal to 0, and equals 0, then we only get one solution, and that solution happens to be a rational number because we're not going to have any square roots in our final answer, and we could have solved by factoring. Okay, let's do another one. We have x equals. So let's just highlight the A, B, and C. There's our A, there's our B, the -5, and then the C is 6. So let's plunk those into our formula. So we have 5 plus or minus, so 5 squared is 25 minus 4 times A times C all over 2 times A. Okay, now let's, oops, I forgot to put the minus sign, it's very small there. Okay, let's just evaluate what we have in the square root now. So 25 minus 48 is -23. Now we actually could stop here because negative square roots cannot be evaluated. So there are actually no real solutions to this equation. We're done. There's no actual answer to this equation. There's no solutions. Sometimes you'll also see it written like this, no real roots. It means the same thing. Okay, so what we've learned here is that the discriminant actually tells us a lot. If the discriminant is negative, we don't even have to solve the problem. There's going to be no real roots. So here, discriminant is, actually I won't say equals, I'll say less than 0. We have no real roots. Okay, so, and then there's also going to be some other scenarios where the discriminant is positive, and in that case, we're going to have 2 solutions. So in the next page, we're going to kind of go through all the different possibilities. There's actually 4 different possibilities for the discriminant, and those have 4 different scenarios for our solutions. So I'm going to scroll down to the next page, and we're going to just fill in this little chart here. So here we have the quadratic formula again written out for us, and just this part in here that I'm highlighting in pink is called the discriminant that we've been talking about, and that gives us a lot of information. So there's 4 scenarios like I mentioned, and those are written in the box here. So let's go through them. The first scenario that we didn't see in the warm-up is if the discriminant is a positive number. There's actually 2 things that can happen if it's a positive number. If that pink b squared minus 4ac is positive and it is a perfect square, then that square root is going to be able to be evaluated, and we're going to get a rational, 2 rational solutions, which means we could have solved this by factoring. Can solve by factoring. So you're going to get 2 solutions. They're going to be rational, and you can solve by factoring when your discriminant is a perfect square. Let's say our discriminant is not a perfect square. Then you're not going to be able to evaluate that square root with a whole number when you're doing the quadratic formula. And so you're going to have a square root in your final answer, and the solutions are going to be irrational. Which, when you have irrational solutions, that means you cannot solve by factoring. Because if you try to solve it by factoring, you won't be able to think of the factors. So cannot solve by factoring. So you would use the quadratic formula, or you could use completing the square to solve the equation. Okay, so that's kind of scenario number 1, when you will have 2 real roots if the discriminant is positive, and they could either be rational or irrational if you have a perfect square or not. Okay, the next 2 scenarios we did see in the warm-up. There's exactly 1 real root or 1 solution when the discriminant equals 0. And we saw in the warm-up as well that 0 is a perfect square in a sense, so you would be able to solve by factoring. So you would get 1 rational solution and you can solve by factoring. Okay, and And then the last scenario is if your discriminant is negative, then you're going to get no real roots, and you can't solve this equation. So of course, your solutions would neither be rational or irrational since there are no solutions. And you wouldn't be able to solve the equation. Okay, so those are the 4 different scenarios. Either you have 2 real roots, and in that case they could be rational or irrational. You could have 1 real root, which would be rational, or you're not going to have any real roots. Okay, let's go to some examples. Number 1, so they have a quadratic equation here. It says without solving. That means we're just going to use the discriminant. We're not actually going to solve this equation. Determine whether it has 1, 2, or no real roots. I'm going to take it one step further here and also ask, can you solve by factoring? Okay, so let's just calculate the discriminant. So my A is 9, my B is -6, and my C is 1. So let's just calculate the discriminant, which is B squared minus 4AC. So in this case, it would be 36, because 6 squared is 36, minus 4 times 9 times 1, which actually is 0. So the discriminant is 0. I have not solved this equation yet. I'm just calculating the discriminant. So I found my discriminant is 0. That means I know lots of things, actually. That tells me there is 1 solution, 1 real root, and I can solve by factoring because 0 is, in a sense, a perfect square. So we're going to get a rational root, and I can solve by factoring. You can go ahead and check yourself. If you do want to solve this by factoring, I'll just do a quick aside. The 2 factors would be 3x minus 1 and 3x minus 1 because it's a perfect square, so the 2 factors would be identical, and we could go ahead and solve it. The only solution would be x equals 1/3. Okay, so calculating the discriminant tells us a lot. It tells us about how many solutions there are, what types of solutions there are, and what method you could use to solve. Okay, let's go ahead and do one more example. This one, it says determine the values for k. So we don't know what k is here. Determine the values of k for which this equation has no real roots. Okay, so let's just highlight. This is my A, this is my B, the 7, and my C is k. So I'm just going to write that down. A is 2, B is 7, C is k. So let's calculate the discriminant. B squared minus 4AC, and it says it has no real roots. That means my discriminant should be negative. Be negative. The way to write that as an equation is I could just write B squared minus 4AC should be less than 0. So let's fill in the numbers that I do have and see if I can isolate for k and see what k should be. So I would have B squared, which is 49, minus 4 times 2 times k has to be less than 0. So I simply plugged in the B, the A, and the C here into those spots into the equation. Okay, so greater than or less than signs work just like equal signs, except that so we're going to isolate the k on one side. So we're going to move the 49 to the other side. So I'll have negative 8k is less than negative 49. I just subtracted 49 from both sides. And I evaluated 4 times 2, which is 8. Now I'm going to isolate k by dividing by negative 8. And I'll get k. And then there's a rule where if you're dividing or multiplying by a negative number, you actually have to flip the sign around. So it's k is greater than 49 over 8. And 49 over 8 is 6.125. So you could write it as a decimal as well. K has to be greater than 6.125. As long as k is greater than 6.125, we will have an equation with no real roots. So part B of this question says, use one value of k to write an equation that has no real roots. So let's just choose, so let's do part B. I'll do it in this space here. You can choose any number. I'm going to do two different options. 7x. I could choose plus 7. Since 7 is greater than 6.125, I automatically know this equation here has no real roots. Let's choose, you can literally choose any number, 7x, as long as it's greater than 6.125. So I'll choose 28. That one would have no real roots as well. I just want to quickly show you on Desmos what that would look like. Y equals 2x squared minus 7x plus k, and we're going to add a slider k. Just going to make sure I have the equation right. 2x squared, plus 7x. So when I look at a graph of this, the solutions are right here, right? So we have two solutions at the moment because they're where this equation equals 0. Now what happens as I slide this slider up, right? Remember we said as long as k is greater than 6, there are no solutions. So as I move this slider up, right here we still have two solutions, 1, 2. But as I move this slider a little bit higher, as long as it's above 6.125, now I have no solutions. There's no place where this graph hits 0 or the x-axis, right? If I move it back below 6.125, I've got two solutions again. But as long as you move it above the 6.125 mark, in fact, right at 6.125, I'll show you, there's exactly one solution because that's where it's hitting the x-axis exactly one time. And then as long as you go above that, we're not hitting the x-axis at all anymore. So that's what it looks like graphically. Okay, so again, the discriminant, it tells you a lot. It tells you how many solutions there are, what types of solutions you have, and how you could solve that equation. That is the end of the lesson.